Okay, here we go. Now, again, absolute values, all right, inequalities. So again, there is a process here, all right, for solving them out. All right, I put a number line down there because oftentimes it's easier to do a number line, but we will demonstrate with the interval notation because I just feel like that's super important. So again, there are pretty much 4 options here, all right? But the same process, Colton, don't worry about it right now. Stop, pay attention to what we're doing. All right. So to solve an absolute value inequality, this is the process. You write it without the absolute value sign. Then you rewrite it again, but you change the inequality sign. All right. So what in the world does that mean? That means, for example, number 1, again, I just said you write it without the absolute value sign. So it's going to be x is less than 6. Then you write it again, but you change the inequality sign and you change the 6. All right. In other words, you change all of the other signs. So you're just going to write x is greater than -6. All right. So you rewrite it without the inequality sign, then you flip the signs. All right. So what in the world does that look like? If you're looking at your number line, here is -6, here is 6. If you are less than 6, your open circle going to the left. If you're greater than -6, your open circle going where? To the right. All right. Now this should bring back some memories from yesterday. So this is technically a what kind of statement? This is an and statement. All right. It's everything between -6 and 6. Now, again, the number line is used to guide you. All right. So your interval notation is from what? -6 to 6. That is your answer. All right. That's how simple this is. All right. So again, write the absolute value without the inequality sign, then write it again, but flip the signs. All right. So if we're looking at number 2, x is greater than 13. All right. If x is greater than 13, we're going to write x greater than 13. Then you rewrite it as what? X is less than -13. At this stage, your brain should be thinking about the numbers a little bit differently because we worked hard yesterday. All right. You should be thinking there are 2 possibilities here. All right. If you're less than -13, here is -13. Less than is going this direction. Greater than 13 is going which direction? To the right. So from yesterday's information, we know over here is -infinity and over here is infinity. So I'm going from -infinity to -13. Then what comes next? U, thank you. From 13 to infinity. All right, that's what I want you to be able to tell me. All right, go ahead.
Are we graphing like the first one? X is greater than 13.
Yeah, that's graphed right here. X is greater than 13. Right here. See that? And then the other one is less.
X is less than.
I did right here. That's this and this. That's the actual physical answer with the number line. Less than -13 is to the left. Do you agree with that? And greater than 13 is to the right. Do you agree with that? Okay, Bruin, good.
How come we didn't do infinity first?
Well, because it's not, it's in between these two. It's not less than. In other words, I was everything greater than -6. Think of the numbers greater than -6, less than 6. That's everything in between. All right. So if you have a good idea about 1 and 2, you should be okay with number 3 now. What, Leah?
So every time that one of the numbers is going left and then the other's going right, there's an infinity and a negative.
Yes, we could say that. All right, so let's look at number 3. So again, we write it, x is greater than or equal to what? 2, and then x is less than or equal to -2. Is everybody with me on that? So now we go to 2 and -2. Let's see where we're at. Here's -2, here's 2. Greater than or equal to 2, solid dot going to the right. Less than or equal to -2, solid dot going where? To the left. Now, Leah, does that make sense? You have negative infinity and infinity.
Yeah, that does, but I'm having trouble figuring out which way they go because -2 is greater than x for the.
Wait a minute. This says x is less than -2, kiddo.
Yeah, which makes -2 greater. So why do you go?
This says x is less than -2. This one right here says x is less than -2. Do you agree with that or not? So that's why it's going to the left. This says x is greater than 2, so it's going where? To the right.
Okay.
You good on that or not? All right, let's double check now for number 4. X is what? No. What does that sign say? We agree? That's okay. It's okay. Less than or equal to 5. And then we write what? There you have it. X is less than or equal to 5, greater than or equal to -5. All right, I didn't go down here and write the interval notation, so I need to jump back real quick. So this is from -infinity to -2, but there's a bracket at -2 and a bracket at 2. What, Palmer?
I'm confused as to where it has to know when you put the bracket.
If it's equal to, it's a bracket.
No, what I'm confused is just why wouldn't the infinity be a bracket?
The infinity is never a bracket. It's never a bracket. You never reach infinity. Infinity is just an idea. All right, so over here, now let's go back to graphing. Plug in -5 and plug in 5. First one is less than or equal to 5, correct? That's what we did yesterday's work, less than or equal to 5. The other one is what? Greater than or equal to -5. So that just means what? -5 to 5. That's it. All right, obviously, those are the 4 cases that deal with all the inequality possibilities. All right. So now the next case is they just get harder as we go down the page, the actual solving. All right. That's it. All right. Isolating the absolute value is the important thing. As we go down, it's kind of annoying because there's lots of work. All right. So let's see what we got. Here we go. Now I'm going to try to do the odds with you. All right. So here we go. Please do what I'm saying. Write it as if there's no absolute value signs. So we just say x minus 6 is less than 7. Then you write it as what? X minus 6 is
Greater than 7.
greater than
-7.
-7. And what do I do to both sides? So that means x is less than, x is greater than -1. -7 plus 6. What's that?
Oh.
See what I mean? You had to change the sign. All right, that's why I'm going slow. Make sure it's just a process, same process all the way down the page. All right, so now you're looking at -1 and you're looking at 13. I'm less than 13 and I'm greater than -1. That means I'm everything what? In between -1, 13. Anybody got a problem with that? All right, let's check out number 7. Three x minus 9 less than or equal to 27. 3x minus 9 greater than or equal to what? -27. Anybody have any trouble with that? Now everybody should be able to say, well, 27 plus 9 is what? 36. And so now x is less than or equal to what? 12. Add 9. Divide by 3. Everybody okay with that? And now we're graphing. Less than or equal to 12. Because the numbers over here, if I take the absolute value of it, it's not going to be less than 27. Only the numbers in between here satisfy that inequality. All right, so let me just make sure you're hearing me. If I plug 0 in, 3 times 0 is 0, right? 0 minus 9 is -9. Absolute value of -9 is 9. 9 is less than 27. Do you agree? But as soon as I pick, for example, let's say -10. 3 times -10 is -30. -30 minus 9 is -39. The absolute value of -39 is 39. 39 is not less than 27. Do you agree? See what I'm saying, right? All right. You're trying to find the solutions that satisfy that absolute value. Yes, ma'am. It says less than. Are you look again? This says less than 12, right? So if we're going less than 12, don't you agree this is less than 12, this direction? Yes or no? You sure? Okay. Like I said, you just honestly, I try to tell kids all the time, you just have to be careful on these. All right, there's lots of ways to make a little mistake. All right, so let's try number 9. Now we got to be careful with number 9 because there's a negative. Please write it twice. Everybody write the equation out twice. Let's see if you get the first part right. 7 minus D is less than 1. 7 minus D greater than what? There's your answers. Now I want to do what? Subtract the 7. Anybody have any problem with that? Now, does everybody agree I have to divide by negative, right? So if I divide by negative, what does that do to the signs? That's right. So you're going to say D is greater than what? And then D is what? Less than 8. So let's go to our number line. Here is 6. Here is 8. I'm greater than 6, correct? And I am. So it's what? 6, 8. We got a problem with that? One, that's not too bad, right? All right, now everybody's got to take a look at 11 and say what's wrong with 11. Palmer. That's right. Add what? You need to add 4. That is correct. You need to add 4. You have to isolate the absolute value. If you forgot that rule, you need to make sure you write it down. Isolate the absolute value. So when I isolate the absolute value, I do what? Add 4 to both sides first. Now I have the absolute value of x is less than or equal to what? What is it? 5. Come on, guys. All right, now let's solve this. Come on. You have 2 equations. Write it the way you see it, then switch the signs. So that's going to be what? X is greater than or equal to. Uh-oh, I'm sorry, I didn't write it the first one. So x is less than or equal to 5 first. And then you're right. X is greater than or equal to what? -5. That's correct. All right, so let's take a look at -5 and 5. Okay. So greater than or equal to -5. Less than or equal to 5. Everybody good with that interval notation? Did I do the interval notation? Yeah. Anybody have any issues with that? Anybody? All right, let's continue on. What do I have to do first now? You could, but better to do what first, though? Add 9. You're treating it just like it's 3x minus 9 is less than 12. Add 9 first. So now I have 3x less than what? 21. Here you go, Colton. Here. We're trying to help you out, bud. Good catch. Shh. Palmer. Now divide by 3. What do I got? X is less than 7. Absolute value of x is less than 7. Do I have any issues with that? And now write it. X is what? Less than 7. Wow, thank you very much. That is correct. So now let's put 7 and -7 in. Less than 7. Greater than -7. Leah, how you doing now? You got it? I did. Right here, look, just to be sure. Here's the first one, here's the second one. I had to isolate first. All right, you had to add 9 and divide by 3. Isolate first. I had to get rid of the -9, and then I had to get rid of the 3 before I solve it.
What did you get? 3? Or -3?
When you added 9, what did you get?
Or what did it say?
To pause. So your problem is this: you didn't isolate first. You don't write two equations until the absolute value has been isolated, okay? So now I'm going to give you a second, and then I want everybody to isolate the absolute value for number 15. Isolate the absolute value for number 15. When I isolate the absolute value for number 15, what do I have to add first? Add 1. Then after I add 1, I have to do what? Divide by 4. You have to add 1 and divide by 4. If I add 1 first, what do I end up with? 16. Then what? Divide by 4. So absolute value of x minus 3 is less than or equal to what? 4. Leah, do you see what we're doing now, right? You're isolating the absolute value first. Isolating the absolute value first. Now rewrite it. Rewrite it as x minus 3 is less than or equal to 4. X minus 3 is what? Greater than or equal to -4. All right, you had to write both equations. You write both equations after you isolate. Write both equations after you isolate. Go ahead. I'm going to right now. You with me? That's the next step. Now, when I add 3, that's when I get x is less than or equal to what? 7. Add 3, x is greater than or equal to -1. Everybody okay with that? So I have less than or equal to 7, greater than or equal to -1. Everybody good with that? And then we just write -1 bracket 7. All right, one more time now, guys. Take a look at 17. All right, what do I have to do first for 17? Subtract 1. Then it becomes what? -21. Now what? Divide by -7. What is that? But what else? 9 minus 4x is what? Help me. Greater than. Thank you. Greater than 3. That's the number one mistake we make on this problem. If you forgot, make sure you make yourself a note. Multiply or divide by a negative. Change the inequality sign. It can't be right if you don't do that. Multiply, divide by a negative. Change the inequality sign. Now you write it twice. All right. So we write 9 minus 4x is greater than 3. 9 minus 4x is less than -3. Everybody good with that? Okay, let's solve this now. What do I do first? -9. -4x is greater than what? -6. Now I'm dividing again by a negative, so again I have to do what? So x is less than 6/4 can reduce to what? 3/2. Greep, how am I doing? You good with that or not? What? I can't hear you. Yeah, we did. Negative divided by negative is a positive. You see it? All right, now we're going to subtract 9 again. -4x is less than what? -12. Divide by -4, so that means x is what? Greater than 3. So here's 3/2. Here is 3. Some people actually ask me, how do I know 3 is greater than 3/2? The whole number doesn't really matter. It's the fact that 3 divided by 2 is what? 1.5. 1.5 is less than 3. So now here we go. X is greater than 3. So I have a greater than 3 going to the right. Less than 3/2 going where? To the left. So I have negative infinity over here. I have infinity over here. Negative infinity to 3/2. Union 3 to infinity. Everybody happy with that? All right, here we go. Next. Multiplying both sides by 3. Good job. 2x minus 9 is greater than 21. Now we rewrite it twice. 2x minus 9 is greater than 21. 2x minus 9 is less than -21. Next process, go ahead and add 9. 2x is greater than 30. So x is greater than 15. Thank you. Adding 9. 2x is less than -12. Therefore, x is so again, if you're greater than 15 and less than -6, here's -6, here's 15. Greater than is going to the right. So everybody should be getting in the hang of this now and understanding that just means negative infinity to -6. Union 15 to infinity. All right, guys, perfect. 2 more to go. What do I have to do first? Subtract 3. Thank you. Subtract 3. Now, what do I do with the inequality signs? Flip it. So we have 6x plus 7 less than or equal to 43.
The negative goes outside.
I got rid of it by dividing by -1. You with me?
Yeah.
Now let's rewrite it. 6x plus 7. Subtracting 7. Are we good with that? Less than or equal to 6. Subtracting 7. Dividing by 6. But -50 divided by 6 can reduce to let's look at our number line now. Here's 6. Here's -25/3. Less than or equal to 6. Greater than or equal to. So now we have all right, last one for me. What do I have to do first? Subtract 5. What is that? Then what? That's what? Are we good with that? Now let's rewrite it twice. And solve that out. So -10x is less than or equal to 14. X is greater than or equal to 7/5. -10x is greater than or equal to -10. X is less than or equal to 1. Greater than -7/5. Here's 1. Everything in between. All right, homework is the evens. You're welcome. Good job today, guys. And I had a little trouble with the donuts, so we only have cookies today.